All right, guys, number 17. Hey, this is a great problem for, understanding these concepts that I have listed here. So let's just go, before we start solving the problem, I just want to quickly go over the vocabulary. So number one, angular velocity. It has this symbol omega, like a W, cursive W, omega. What is angular velocity? Well, what are the units? What would be the units for angular velocity? So this problem has a bug sitting on the edge of this rotating disk. So say this bug rotates around one time in 1 second. Just keep it real simple. What would be the angular velocity if the bug made 1 revolution per second? The angular velocity there would be what? 1 revolution per second, which would be identical to what? 360 degrees per second, which would be 2 pi radians per second. So that's angular velocity. Revolutions per second, degrees per second, radians per second. Hey guys, when in doubt, which unit do you want to be in? Radians. Because there are certain cases, which I'm going to mention in a minute, there are certain cases where you have to be in radians. Okay? All right, second concept, tangential velocity. What is tangential velocity? Well, what's the unit for tangential velocity? Is it going to be one of these, revolutions per second or degrees per second or radians per second? What is tangential velocity measured in? Meters per second. It's a linear velocity. So if this object, so this disk here is rotating around, let's say the motion is that way, the disk is going around like this. If this object suddenly left the circle, how would it leave the circle? Tangent to the circular path that it was in. So let's say it left the circle up here. If it left the circle right there, tangent to the circular path. That's why we call it tangential velocity. Okay, so tangential velocity, it's v sub t. Okay, what are some different ways to calculate tangential velocity? There's 2 main ways to do it. Tangential velocity, the first equation, angular velocity times radius, right? This angular velocity, in this case here, it must be radians. When you're using this equation, it has to be radians. All right? What's the other way to get tangential velocity? Well, if something's going around in a circle like this, what's the distance traveled in one circle? Because velocity is basically distance over time, right? What's the distance around one circle? The circumference, 2 pi r. What do you call the time for one circle? The period. Okay, so basically what you're doing is you're going distance over time. You take the distance for one circle, divide by the time for one circle. Close this door. All right, third on the list, angular acceleration. Okay, let me clean this up. All right, so angular acceleration. Well, what the heck is angular acceleration? Say that this disk is going faster, 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 faster. It starts to speed up in an angular sense. What would angular acceleration be? Well, the symbol for angular acceleration is alpha. Okay, that's our symbol for angular acceleration. Look, what's the definition of regular acceleration? Regular linear acceleration is what? Change in velocity over time. So what's angular acceleration going to be? It's going to be change in the angular velocity over time. Does that make sense? So for example, like I'm just going to make it up. What if this angular acceleration was, let's just make something easy. I like the number 1. 1 revolution per second squared. That would be acceptable. What would that be telling you? This would be telling you 1 revolution per second every second. Every second, what's that object, what's the disk doing? Going 1 revolution per second faster. Angular acceleration. Okay? Tangential acceleration, number 4 on the list. What would tangential acceleration be? Well, so here we have the object. It's got a tangential velocity. Now look, tangential velocity and tangential acceleration go hand in hand, right? Because what happens if this disk has an angular acceleration? Well, if there's an angular acceleration, what's happening to the disk? It's going around faster and it's speeding up, right? It's going faster, 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 faster. Would an angular acceleration cause the tangential velocity to change? Yeah. So that would be called a tangential acceleration. A tangential acceleration, A sub t, would be any change in the tangential velocity over time, which is going to be caused from an angular acceleration. Now look, how could you find tangential acceleration? There's an equation for it. To get tangential acceleration, you take the angular acceleration times the radius. It's easy to remember because what was the equation for tangential velocity? Tangential velocity was what? Angular velocity times radius. So tangential acceleration, you take the angular acceleration times the radius. If you want tangential velocity, that's angular velocity times radius. All right, then last on the list is centripetal acceleration. Which way does centripetal acceleration point? I derived this for you in the notes last week. Which way does centripetal acceleration point? To the center, which I'm not going to explain again here because this video would be super long, but you can go watch my lecture on centripetal acceleration to see why it points to the center. Okay, and then what's the equation for centripetal acceleration? V squared over r. Hey, I forgot to mention one thing. Which way does tangential acceleration point? It's kind of an obvious. Who's buried in Grant's tomb? Which way does centripetal acceleration point? To the centripetal accelerations to the center. Which way is tangential acceleration? It's tangent to the circle. Okay. All right. Let's do this problem. All right. So here's the info we have. So the disk starts at rest. Angular velocity initial is 0. I'm going to do this in radians. Angular velocity final. So this disk speeds up right here to this angular velocity, 78 revolutions per minute. We need to convert this into radians per second. When in doubt, be in radians, okay? Because there are those two equations I showed you where you have to be in radians. So 78 revolutions per minute. When you convert this to radians per second, this is 8.168 radians per second. Okay, this all takes place in a time of 3 seconds, and angular acceleration is a question mark. Okay, first question here. What is the tangential acceleration of a bug on the rim of a 10-inch diameter disk? Okay, the diameter is 10 inch, so what's the radius? 5 inches, but are we going to leave that in inches? No, you got to convert that. So 5 inches converted to meters is 0.127 meters. Okay, so that's our radius. All right, how are we going to find the tangential acceleration? Let me remind you of something. So for part A, what's a way to get tangential acceleration? You take the angular acceleration times the radius. Okay, so what do we got to calculate? the angular acceleration. We got to get this angular acceleration. So to do that, angular velocity final equals angular velocity initial plus alpha t. What's the initial angular velocity? 0. The disk started at rest. So the angular acceleration is going to be angular velocity final over time. All right, so angular velocity final is 8.168 radians per second in a time of 3 seconds. This gives an angular acceleration of 2.72 radians per second squared. So when you're plugging in up here, you're going to go 2.72 radian per second squared. The radius is 0.127 meters. So this gives a tangential acceleration of 0.35. meter per second squared. Which way is that acceleration directed? So let's say the bug is right here. Which way is the tangential acceleration? Boom, it's that way. What does this mean, you guys? What does 0.35 meter per second squared mean? Every second, the velocity of the bug is 0.35 meters per second greater, tangentially. Tangent to the circle. Okay, second question. When the disk is at its final speed, what is the tangential velocity? Okay. So when the disk is at its final speed, what's the tangential velocity? This is easy. What's the equation we could use for tangential velocity? Angular velocity times radius. Okay, so the angular velocity is 8.168 radians per second. The radius is 0.127 meters. This gives a tangential velocity of 1.04 meter per second. So look, if this bug left the circle at that exact moment, what would be its velocity tangent to the circle? 1.04. That's all tangential velocity is. All right, part C is the trickiest part. It's asking for 3 different things. Okay, part C is asking for 3 different things. Okay, so let's put our information here again. So angular velocity initial is 0. Angular velocity final is a question mark now because they changed the time. Our angular acceleration is still the same. That didn't change. It's still 2.72 radian per second squared. So now they're telling us we're focusing at t equals 1 second. Okay? So what's the angular velocity going to be at t equals 1? Here's your angular acceleration, 2.72 radians per second squared. What does this mean? 2.72 radians per second every second. So what's going to be the angular velocity at 1 second? 2.72. Okay, 2.72 radians per second. All right, so first on the list. So part C, we have 3 different things. We're looking for tangential acceleration, centripetal acceleration, total acceleration. Okay, the tangential acceleration. Is that the same or different from, because we already calculated that up here, right here, for part A. Tangential acceleration, but we did that at t equals 3. Is it going to be the same or different for t equals 1? It's going to be the same, right? Because look, so we're part C. The tangential acceleration is angular acceleration times radius. Did the angular acceleration change when, so, you know, we were looking at t equals 3, now we're looking at t equals 1. Is the angular acceleration the same or different? It's the same. 2.72 radians per second squared. The radius is 0.127. So this gives a tangential acceleration. It's still 0.35. Okay, centripetal acceleration. Do we have an equation for centripetal? We do. What's the equation for centripetal? V squared over R. Now, do we know the so this is a tangential right there. Do we know the tangential velocity at t equals 1 yet? Could we get it? Yeah. So let's get that. Or actually, here's what you could do. What's the equation for tangential velocity? It's angular velocity times radius. So take this, plug it in there. So this is going to be angular velocity times radius squared over r. So this gives us centripetal acceleration equals angular velocity squared times r, right? So you got to distribute that. And then one of the r's cancels. This must be in what? Radians. Okay, what's the angular velocity at t equals 1? 2.72. The radius is 0.127. So this gives us a centripetal acceleration of 0.94. Final thing, the total acceleration at t equals 1. The total acceleration. So here's what we know, guys. So let's say the bug is right here. The tangential acceleration is tangent to the circle. And that was equal to 0.35. The centripetal acceleration points to the center. And that's equal to 0.94. How could we get the total acceleration? These are the two accelerations we have. We have a tangential acceleration and a centripetal acceleration. What does this look like to you? As a triangle. But look, what does this look like to you? I mean, to get the total acceleration, to get the total acceleration, can we just go, okay, 0.35 plus 0.94, just add those together? Because they point in different directions, right? This is a vector problem. How do you add vectors together? Tip to tail. Put these vectors together, tip to tail. The centripetal acceleration is 0.94. The tangential acceleration is 0.35. So how do you add these together? So the total is going to be the hypotenuse. The acceleration total, so you use Pythagorean theorem. When you do Pythagorean theorem, you get 1 meter per second squared. And then you're also going to want this angle. So that theta is going to be tangent inverse opposite over adjacent. So that comes out as 20 degrees off the centripetal acceleration. It's 20 degrees off the centripetal acceleration. So the final answer, the total acceleration, 1 meter per second squared, comma, 20 degrees off centripetal acceleration. You guys get it?